In this session, we're going to be having a look at simple equations in one variable. And the equations will be linear. That means there'll be no x squared terms, no x cubes, just x's and numbers. So let's have a look at the first one. 3x plus 15 is equal to x plus 25. An important thing to remember about any equation is this equal sign represents a balance. What that equal sign says is that what's on the left-hand side is exactly the same as what's on the right-hand side. So, if we do anything to one side of the equation, we have to do it to the other side. If we don't, the balance is disturbed. If we can keep that in mind, in whatever operations we perform on either side of the equation, so long as it's done in exactly the same way on each side, we should be all right. Our first step in solving any equation is to attempt to gather all the x's together and all these free-floating numbers together. So, to begin with, we've got 3x here and x here. So if we take an x away from both sides, we take an x off there and an x off there. That will give us 2x plus 15 is equal to 25. And now we need to get the numbers together, these free numbers together, so we can see that if we take 15 away from that side and 15 away from that side, we'll have no numbers left, just a 2x. And taking 15 away, that gives us 10. And of course, that means x must be equal to 5. That was relatively straightforward. Lots of plus signs, no minus signs, which we know can make complications, and also no brackets. So let's introduce both of those. We'll take 2x plus 3 is equal to 6 minus 2x minus 3. Now this side, this right-hand side, needs a little bit of dealing with. It needs getting into shape. So we have to remove this bracket. So 2x plus 3 equals 6. Now we're taking away 2x, so that's minus 2x. And then we're taking away minus 3. And when we take away minus 3, that makes it plus 3. Before we go any further, we need to tidy this right-hand side up a little bit more. 2x plus 3 is equal to 9 minus 2x. And now we're in the same position at this line as we were when we started there. So we need to get the x's together, which we can best do by adding 2x to each side. Add 2x so that minus 2x plus 2x at this side gives us no x's. And at this side it's going to give us 4x. So we add 2x to each side. 4x plus 3 is equal to 9. Because minus 2x plus 2x, no x's. Now we can take 3 away from each side. 4x equals 6. And so x is 6 divided by 4. And we'd want to write that in its lowest terms, which is 3 over 2, a perfectly acceptable answer, or 1.5. So either of these are acceptable answers. This one isn't, because it's not in its lowest terms. It must be reduced to its lowest terms. So either of those two are okay as answers. With all of these equations, we should strictly check back by taking our answer and putting it into the first line of the equation and seeing if we get the right answer. So if we do this, 5, 3 5s are 15, and 15 is 30. 5 plus 25 is also 30. So that balance that we talked about at the beginning is maintained. And if you take this number, 3 over 2, or 1.5, and substitute it back into here, we should find again that it gives us the right answer, that both sides give the same value. They both balance. So let's just do that. Let's take it as the 1.5. So 2 times 1.5 is 3, plus 3 is 6. So we've got 6 at that side. Here, with 6 take away. Now, let's deal with this bracket, just this bracket on its own, nothing else. So 2x, that's 3. Take away 3, that's nothing. So we're just left with 6. And we calculated this side to be 6. 6 does equal 6. So again, we've got that balance. So we know that we've got the right answer. Let's carry on and have a look at one or two questions with more brackets in, and this time numbers outside those brackets as well. So in a sense, what we're doing is we are increasing the complexity of the equation. But the simple principles that we've got so far are going to help us out. Because no matter how complicated it gets, and this does look complicated, the same ideas work all the time. So we begin by multiplying out the brackets and taking care, in particular, with any minus signs that come up. So 8 times by x is 8x, and 8 times by minus 3 is minus 24. So we've multiplied everything inside that bracket by what's outside. So with 8 times by x and with 8 times by minus 3. Now we remove this bracket, we're taking away 6, so that's minus 6, and we're taking away minus 2x. And a minus minus gives us a plus, so that's plus 2x. Equals 2 times x here is 2x, 2 times 2 is 4, and now we've got to multiply by minus 5. So we've got minus 5 times by 5, that's minus 25, and minus 5 times by minus x, so that's plus 5x. Each side needs tidying up. We need to look at this side and gather x's and numbers together. So with 8x plus 2x, that's 10x. Take away 24, take away 6, that's taking away 30 altogether. 2x and 5x gives us 7x. Add on 4, take away 25. Now that's the equivalent of taking away 21. Let's get the x's together so we can take 7x away from each side. So we would have 3x minus 30 there equals just minus 21, because we've taken that 7x away. Add the 30 to each side, because minus 30 plus 30 gives us nothing, and add it on over here. So we get 3x equals, now, 30 added to minus 21. Well, it's just the same as 30 take away 21. So the answer is 9. And 3 times by something to give us 9 means the something, the x, must be 3. And again, we ought to be able to take that, put it back into this line and see that in fact we've got the correct answer. So let's just try. 3 minus 3 is 0. 8 times by 0 is still 0. So we can forget about that term. 2 times by 3 is 6. So 6 take away 6 is nothing. So we've actually got nothing there, 0, and nothing there, 0. So there's nothing at this side of the equation. So this right-hand side has got to come out to 0 as well. Let's see that it does. 3 plus 2 is 5, and 2 5s are 10. 5 take away 3 is 2, and 5 2s are 10. So we've got 10 take away 10 gives us nothing again, so we've got nothing on this side. The equation still balances with this value. So this is our one and only solution. We take a final example of this kind with x plus 1 times by 2x plus 1 equals x plus 3 times by 2x plus 3 minus 14. Now I did say that these were linear equations, that there would be no x squared terms in them. But when we start to multiply out these brackets, we are going to get some x squared terms. Let's have a look, see what actually does happen. So we do x times by 2x, that's 2x squared, and x times by 1, so that's plus x. 1 times by 2x, so that's plus 2x, and 1 times by 1 plus 1 equals x times by 2x, that's 2x squared, x times by 3, 3x, 3 times by 2x, that's 6x, 3 times by 3, that's 9, and finally the end bit, take away 14. Now we need to tidy up both sides here. 2x squared plus 3x plus 1 equals 2x squared plus 9x, taking these two terms together, plus 9 minus 14. And this needs a little bit more tidying. But before we do that, let's just have a look at what we've got. We've got a 2x squared there and a 2x squared there. They are both positive, so I can take 2x squared away from both sides. That means that the 2x squared vanishes from both sides. So let's do that. Take 2x squared from each side, and that leaves us 3x plus 1 is equal to 9x, and now we can do this bit. 9 take away 14, well, that's going to be take away 5. I still have the 5 to subtract. Now we're back to where we used to be, getting the x's together, getting the numbers together. We can subtract 3x from both sides. So that gives me 1 equals 6x minus 5. We can add the 5 to both sides, so that's 6 equals 6x, and so 1 is equal to x. And again, we can check that this works. We can substitute it back into here. 1 plus 1 is 2. 2 1s are 2 and 1 is 3. So effectively we've got 3 times by 2 at this side, which gives us 6. Here, 1 plus 3 is 4. 2 times by 1 is 2, plus 3 is 5. So we've got 4 times by 5. So altogether there's 20. Take away 14 is again 6. So again, this equation is balanced exactly when we take x to be equal to 1. Now those equations that we've just looked at have really been about whole numbers. The coefficients have been whole numbers. Everything's been in terms of integers. What happens when we start to get some fractions in there, some rational numbers? How do we deal with that? So again, we're going to add on more complexity. But again, the rules are the same. What we do to one side of the equation, we must do to the other side in order to preserve that particular balance. So, let's introduce some fractions along with some brackets. So with 4 brackets x plus 2 all over 5 is equal to 7 plus 5x over 13. We've got some fractions here. Numbers in the denominator, 5 and 13. We want rid of those. We want to be able to work with whole numbers, with integers. So we have to find a way of getting rid of them. And that means we have to multiply everything, because what we do to one side we must do to the other, by the common denominator. And the common denominator for 5 and 13 is 65. That's 5 times by 13. So let's do that. Let's multiply everything by 65. And I'll write it down in full so that we can see it happening. So we have 65 times 4 brackets x plus 2 over 5. Then we have 65 times by 7. Remember I said we had to multiply everything. So that's not just these fraction bits, it's any spare numbers that there are around as well. Plus 65 times by 5x over 13. Now let's look at each term and make it simpler, tidy it up. Well, for a start, 5 will divide into 65. So 5 into 5 goes 1, and 5 into 65 goes 13. And then 4 times by 13, well, that's 52. So we have at that side 52 times by x plus 2 equals. That's in a nice familiar form. We're used to that sort of format. We've arrived at it by choosing to multiply everything by this common denominator. Now let's tidy this side up. 7 times by 65. Well, that's pretty tall order. Let's try it. 7 5s are 35. 7 6s are 42, and the 3 is 45. Here we've 65 times 5x over 13. Well, 13 goes into 13 once, and 13 goes into 65 5 times. So with 5 times by 5x is 25x. And you may say, what happened to these 1s? Well, if I divide by 1, it stays unchanged, so I don't have to write them down. And now, what are we left with? An equation that we're used to handling. We've met these kind before. So let's multiply out the brackets, get the x's together, and solve the equation. So we multiply out the brackets, 52x, 52 times 2 is 104, equals 455 plus 25x. Take the 25x away from each side. So that gives me 27x there, and no x's there. Take the 104 away from each side, which gives me 351. And now, lots of big numbers, but really that shouldn't be a problem to us. 351 divided by 27, well, certainly it goes once. There's 127 in the 35 and 8 over, and 27's into 81, well, they're going to go 3 times. So our answer is x equals 13. And we can go back and check it and make sure that it's right. So let's do that. 13 plus 2, well, that's 15. 15 divided by 5 is 3, and now times by 4, so that's 12. So hang on to that number, 12 at that side. 5 times by 13, but divided by 13. So the answer is just 5. Plus the 7 is again 12, the number that we got at this side. So this answer is correct. It balances these two sides of the equation. Let's practice that one again and have a look at another example. So we take x plus 5 over 6 minus x plus 1 over 9 is equal to x plus 3 over 4. But we haven't got any brackets. Does that make any difference? The thing you have to remember is that this line not only acts as a division sign, but it acts as a bracket. It means that all of x plus 5 is divided by 6. So it might be as well if we kept that in mind and put brackets around these terms, so that we're quite clear in what we've written down that these are to be kept together and are all divided by 6. These two are to be kept together and are all divided by 9. And similarly here, they're all divided by 4. Next step, we need a common denominator. We need a number into which all of these will divide exactly. Now we could multiply them all together and we'd be certain, but the arithmetic would be horrendous. 6 times 9 times 4, very big number. Can we find a smaller number into which 6, 9 and 4 will all divide? Well, a candidate for that is 36. 36 will divide by 6. 36 will divide by 9, and 36 will divide by 4. So let's multiply throughout by that number 36. So we have 36, and because we've put the brackets in, we're quite clear that we're multiplying everything over that 6 by the 36. Minus 36 times x plus 1 all over 9 equals 36 times by x plus 3 all over 4. So we've made it quite clear by using the brackets what this 36 is multiplying. And now 6 into 6 goes 1, and 6 into 36 goes 6. 9 into 9 goes 1, and 9 into 36 goes 4. 4 into 4 goes once, and 4 into 36 goes 9. So now I have this bracket to multiply by 6, this bracket to multiply by 4, and this bracket to multiply by 9. I don't have to worry about the ones because I'm dividing by them, so they leave everything unchanged. So let's multiply out. 6 times by x is 6x plus 30. 6 times by 5. Now this is a minus 4 I'm multiplying by, so I need to be a bit careful. Minus 4 times x is minus 4x. Minus 4 times 1 is minus 4. Equals 9x, and 9 threes are 27. So now I need to simplify this side. 6x take away 4x, that's just 2x. 30 take away 4 is 26, and that's equal to 9x plus 27. Let me take 2x away from each side. So I have 26 equals 7x plus 27. And now I'll take the 7 away from each side, and I'll have minus 1 is equal to 7x. And so now I need to divide both sides by 7, and so I get minus a seventh for my answer. Don't worry that this is a fraction. Sometimes they work out like that. Don't worry that it's a negative number. Sometimes they work out like that. Let's have a look at another one, because this is a process that you're going to have to be able to do for quite complicated questions. So we'll take 4 minus 5x all over 6, minus 1 minus 2x all over 3 equals 13 over 42. What are we going to do? First of all, let's remind ourselves that this line not only means divide 4 minus 5x by 6, but it means divide all of 4 minus 5x by 6. So let's put it in a bracket to remind ourselves, and let's do the same there. Now we need a common denominator, 6 and 3 and 42. Well, 6 goes into 42 and 3 goes into 42 as well. So let's choose 42 as our denominator and multiply everything by 42. So we'll have 42 times 4 minus 5x all over 6 minus 42 times 1 minus 2x all over 3 equals 42 times 13 over 42. 6 goes into 6 once, and 6 goes into 42 7 times. 3 goes into 3 once, and 3 goes into 42 14 times. 42 goes into itself once, and again once. So now I need to multiply out these brackets and simplify this side. So 7 times by 4 gives us 28. 7 times by minus 5 gives us minus 35x. Now here we have a minus sign and a 14, so it's minus 14 times by 1, minus 14. And then it's minus 14 times by minus 2x, so it's plus 28x. Remember, we've got to take extra care when we've got those minus signs. 1 times by 13 is just 13. Now I need to tidy this side up. 28 take away 14 is just 14. 35 minus 35x plus 28x. Well, what's the difference there? It is 7. So it's minus 7x equals 13. Take the 14 away from each side with minus 7x equals minus 1, and divide both sides by minus 7. Minus 1 divided by minus 7 is just a seventh. Again, fractional answer, but not to worry. Well, we've looked at these. Now we want to have a look at a type of equation which occasionally causes problems. This particular equation, or kind of equation, looks relatively straightforward. But as the numbers get rather more difficult, it can cause difficulties. So we've got 3 over 5 equals 6 over x. Straightforward. But what do we do? Let's think about it first of all in terms of fractions. This is a fraction 3/5, and it is equal to another fraction which is 6. Well, fairly obviously, 3/5 is the same fraction as 6/10. And so therefore, x has got to be equal to 10. But that's not going to happen with every question. It's not going to be as easy as that. We're going to have to juggle with the numbers. So how do we do that? Well, again, we need a common denominator. We need a number that will be divisible by 5 and a number that will be divisible by x. And the obvious choice is 5x. So let us multiply both sides by 5x. So we 5x times by 3/5 equals 5x times by 6 over x. And now 5 goes into 5 once, and 5 goes into 5 once there. X goes into x once, and x goes into x once there. Now let's remember that we're multiplying by these, so we have 1 times x times 3, that's 3x, and divided by 1, so it's still 3x, equals 5 times 1 times 6, which is just 30, and divided by 1, so it's still 30. 3x is equal to 30, so x must be equal to 10, which is what we had before. Is there another way of looking at this equation? Well, yes, there is. If two fractions are equal that way up, they're also equal the other way up. This makes it easier still, because all that we need to do now is multiply by the common denominator, and we can see what that common denominator is. It's quite clearly 6, because 6 divides into 6 and 3 divides into 6. So we had 5 over 3 was equal to x over 6, and we're going to multiply by this common denominator of 6. So 6 goes into 6 once on each occasion, 3 goes into 3 once, and into 6 twice. And so again, x is equal to 10. 2 times by 5, 1 times by x. Whichever way you use doesn't matter. They should come out the same. There's no reason why they shouldn't. But you do have to be careful. The number work can be a bit tricky sometimes. Let's have a look at just a couple more. 5 over 3x is equal to 25 over 27. Okay, what I think I'm going to do with these is flip them over. 3x over 5 is equal to 27 over 25. I can see straight away I've got a common denominator here of 25. 5 goes into 25 exactly, and so does 25. So if I do that multiplication, 25 times 3x over 5 is equal to 25 times 27 over 25. Then 25 goes into itself once on each occasion. 5 goes into itself once, and 5 goes into 25 5 times. So I have 15x, 5 times by 3x is equal to 27. And so x is 27 over 15, dividing both sides by 15. And there is here a common factor between top and bottom of 3, which gives me 9 over 5. So that's an acceptable answer because it's in its lowest forms, or I could write it as 1 4/5, which is also an acceptable answer. Now, some of you may not like what I did there when I flipped it over. And you might want to think, well, how would I do it if I had to start from there? So let's tackle that in another way. So again, 5 over 3x is equal to 25 over 27. And this time, we're not going to flip it over. Let's look for a common denominator here between these two. So we want something that 3x will divide into exactly and something that 27 will divide into exactly. Well, 3 will divide into 27. So the 27, so to speak, ought to be a part of our answer. What we need is an x. Because if we had 27x, 3x would divide into it 9 times, and the 27 would just divide into it x times. So that's going to be our common denominator, the thing that we are going to multiply both sides by, 27x. So we can look at this and we can see that x divides into x once and x divides into x once there. We can also see that 3 divides into 3 and 3 divides into 27 9 times. And over here, 27 goes into 27 once each time. So I have 9 times 1 times 5, and 9 5s are 45, divided by 1 times 1, which is 1, so it's still 45, equals 1 times by 25, and times by the x there, 25x. Now I need to divide both sides by 25, so I have 45 over 25 equals x. This is not in its lowest terms. I can divide top and bottom by 5, giving me 9 over 5 again, which again I can write as 1 4/5. Let's take one final example. This time let's look at some fractions, but this time mysteriously the x is already on the top. Well, that's really good for us. All we need to do is look at what's our common denominator. Well, 7 and 49. What number divides exactly by both of these? And it will be 49. So we just need to do 49 times by 19x over 7 equals 49 times 57 over 49. 49 goes into 49 once each time, and 7 goes into 49 7 times. And so I have 7 times by 19x equals 57. And you might say, well, hang on a minute, shouldn't you have multiplied out that first? Well, I didn't want to. Why didn't I want to? Well, sometimes when you play darts, your arithmetic improves. And triple 19 on a dartboard is 57. So 19 divides into 57 3 times. And I don't want to lose that relationship. So I'm going to divide each side by 19. So 7x is equal to 3, which means x must be 3 over 7. Playing darts does help with arithmetic. We finished there with simple linear equations. The important thing in dealing with these kinds of equations and any kind of equation is to remember that the equal sign is a balance. What it tells you is that what's on the left-hand side is exactly equal to what's on the right-hand side. So whatever you do to one side, you have to do to the other side. And you must follow the rules of arithmetic when you do it.